Hey there. Hope things are going well for you. We're boiling down to like the second to last lesson on rational functions and relations, and now we've made our way to the solving process. And pretty much everything we've learned in the past couple of lessons are going to be applied in solving. So we're going to factor, we're going to state our domain, we're going to find the least common multiple of our equation by looking at every denominator. Then we're going to multiply every term by that least common multiple. And this is going to allow us to cancel the denominators. So I'm actually going to get rid of my denominators. And this is going to allow me to either solve just a simple linear equation or to solve a quadratic by factoring or using the quadratic formula. Then we just have to check, particularly if we've solved a quadratic, we just have to check that we don't come up with a value that actually conflicts with the domain, like maybe it produces an exclusion in the domain. Okay, so let's try one. This is one of the simplest ones. We just have a denominator on the left-hand side, and as I look at it, we don't need to factor. Why don't you go ahead, answer the video question, and state the domain. All right, so here we go. My domain, 1 minus 2x. I set that equal to 0 and solve. So a half is equal to x. So my domain is going to be any x is a possible solution except when x equals, I don't, make sure I didn't say a negative a half. That should be positive a half. Okay. All right, now we're going to find the least common multiple of the denominators. Well, honestly, there's just one there. So that's our common denominator, 1 minus 2x. And now what I'm going to do is I'm going to multiply both sides by it. I'm going to go ahead and put it in red. Okay, so I'm going to go 1 minus 2x. I'm going to have it here, and I'm also going to have it here, 1 minus 2x. I got to multiply both sides by it. I just want it to be in a different color, and I don't want to spend a lot of time going back and forth. So here I'm going to multiply it by what's on the left, x plus 2 over 1 minus 2x. And then on this side I had a 5 that I'm multiplying it by. Okay. So now I can cancel. I can cancel this 1 minus 2x with that 1 minus 2x, and I'm left with x plus 2 is equal to 5 times 1 minus 2x. So now I can distribute, and I get x plus 2 is equal to 5 minus 10x. I can move my x's to the left, and I get 11. X plus 2 is equal to 5. I move my 2 over to the other side. That gives me 11x is equal to 3, which means that x is equal to 3 over 11. And you can check that and just double check that it doesn't conflict with the domain exclusion. Why don't you go ahead and try the video question associated with this slide. All right, hopefully that went well for you. If you have a question, make sure you write down what you did so that we can discuss it and help you improve. This next equation is not really that much different. I just have a fraction on both sides now, but notice that my denominator is identical. Okay, so why don't you go ahead and factor the numerator as part of the video question, state the domain, and then find the least common multiple of the denominators. All right, so if I factor this, let me do it in purple. This is going to be x plus 3 times x minus 1 I think I'm going to end up, well, I know I'm going to end up multiplying that back together again, but it might help if there's something that we can cancel with from a denominator. Not in this case, but in other problems that does happen. State the domain. Here, x plus 2 equals 0. So x cannot equal negative 2. So my domain is, I could have any solution would be allowed except if the solution equaled negative 2. Okay, so our domain here is telling us what are allowable solutions. Okay, not necessarily that every x is a solution. We know that's not true, but we could choose from all real numbers except x can't equal 2. So if we get negative 2 as a solution, we have to eliminate it. And so the least common multiple of this equation was x plus 2. So now let's multiply every term. And so I get, I'm going to put my original in here, x minus 1, x plus 2 equals, and I have x plus 3, x minus 1, here's x plus 2. So that's my original. Now I'm going to go ahead and write in my least common multiple that I'm multiplying by. That's this, and x plus 2. Now I'm going to cancel where I can. So now I get x minus 1 is equal to, these cancel, x plus 3 times x minus 1. Now I got to multiply those back together again. You'll get a feel for when to factor the numerator versus when not to factor the numerator. This is x squared plus 2x minus 3. I'm going to move all my terms to one side. I have a quadratic, so that means I'm going to either have to factor or I'm going to have to use the quadratic formula. So get all your terms together. And doesn't equal, it's plus. So I'm going to move my x's together. So that gives me plus an x. I'm going to move my 1 over, so that's going to give me minus 2. And then this is going to factor into x plus 2 and x minus 1. Okay, so now this factor is going to produce x equals negative 2. Let me see if I can get this to fit a little bit better. So this is x plus 2 and x minus 1. So this one is x equals negative 2. This one is x equals 1. Well, look, we said up here that x can't equal negative 2. So if our process produces a solution of negative 2, we have to get rid of it. So it's just x equals 1. All right? Okay. Now we're going to try one that requires a little bit of factoring. On the denominator, we're going to state the domain, find the least common multiple, multiply through by that least common multiple, cancel, and solve. Okay, so let's factor this one right here. This is x plus 3, x minus 3. Okay, so my domain, this factor says x can't equal 3. This factor says x can't equal negative 3, and these are just repeats, right? So there's my domain. Okay. Now I have to find my least common multiple. Well, that's going to be x plus 3, x minus 3. And now I have to multiply every term by that least common multiple. All right, so here's what I have. I'm going to kind of start up here. I have x over x minus 3, and then I have x over x plus 3, and then I have 2 over x plus 3, x minus 3. Okay? All right, and now I have to multiply it by this x plus 3, x minus 3 for every single term. All right, and x plus 3, x minus 3, and then again here, x plus 3, x minus 3, okay? All right, so now this x minus 3 here in the denominator, the first term, is going to cancel with the x minus 3 in the numerator, okay? This x plus 3 is going to cancel with the x plus 3 there, and both of these are going to cancel here. So now what I end up with is x times x plus 3 plus x times x minus 2. Oh, that's not a minus 2. That's a minus 3. Equals 2. Okay, now I fixed that. Now we're going to distribute. We've canceled the denominators. Now we're going to distribute, collect like things, and check our solution. So I get x squared plus 3x plus x squared minus 3x is equal to 2. X squared plus x squared, that's 2x squared, plus 3x minus 3x, those cancel. So I get x squared is equal to 2, 2x squared is equal to 2, x squared is equal to 1, and x is equal to plus or minus 1, right? And then we would just check those in our original, and we would check those to make sure that they didn't conflict with the domain, which they don't. So an application of this is you'll see it like when you're traveling and there's the influence of wind or a current. You might have seen it with streams in Algebra 1, but basically you're driving or you're bicycling or you're flying, and you have the speed of your vehicle, and in addition to that you have effect of the wind. So in one direction the wind is working against you, making you go slower, and in the other direction the wind is helping you, making you go faster. All right, so what we do is we kind of set up an equation. They're rational equations, and we solve it. So let's read through this process and let's see what we can come up with. It says you often ride your bike 4 miles to a store, and your speed, so that's the speed, just you on the bike, is 10 miles per hour when there's no wind, no effective wind. On today's trip to and from the store, to and from, so that's a round trip, it took 1 hour. Find the speed of the wind. Well, this is a typical case where you're going to use distance equals rate times time, or in this case, because we know the time, we have our time is equal to distance over our rate, okay? All right, so we know that the total time, round trip, has to equal the trip to the store plus the trip back or from the store. Okay, so we know our total trip took 1 hour. That's the time. We don't know how long it took us to get to the store, but we do know that we went 4 miles. 4 miles was our distance, and our rate was what we were pedaling, 10. And one of these directions you have to be with the wind, and one of them you have to be against the wind. So it's going to be 10 for 10 plus the wind going in one direction. Let's just say it's going to the store. It doesn't matter which which one. One of them has to go, you have to get faster with the wind, and then the other trip you have to get slower because of the wind. Okay? So now I'm going to multiply both sides by my least common multiple, which is 10 plus W, and 10 minus W. So I have 10 plus W times 10 minus W is going to be, and I have to multiply this times this too, so my 10 plus W's are going to cancel. So I have 4 times 10 minus W plus the 10 minuses are going to cancel here, 4 times 10 plus W. Now I'm going to FOIL, so I get 100. Oh, that looks really bad. So I get 100. Then I get plus 10W and minus 10W. Those cancel. So minus W squared is going to be 40 minus 4W plus 40 plus 4W. And so notice that the plus 4 and the minus 4 cancel out. So I have 100 minus W squared is equal to 80. I'm going to keep moving this way. I'm going to move my 100 over, so I get negative W squared is equal to negative 20. I'm going to multiply through by a negative 1, and I get W squared is equal to 20, and then W is equal to, it would be plus or minus root 20, but we wouldn't have negative wind. So what we're going to do is we're just going to take the positive value. So that is 2 root 5, which is roughly equal to 4.5 miles per hour. Right? You can just plug that into your calculator. All right, the last thing we're going to do is we're going to solve literal equations. I think we've seen this before, but basically we're just going to apply that property of multiplying both sides by the least common multiple of the denominator, and then we're going to isolate the letter that we're looking for. So I have an E and an M and a C, so I'm going to multiply every term by E, M, C, and cancel where I can. E, M, C. And E, M, C. Okay, here my E's cancel out, so I have MC squared minus, my M's cancel, my C cancels, E times 1 is E, equals 0 times that is 0. So I get E is equal to MC squared, right? Energy equals mass times the speed of light squared. That's Einstein's theory of relativity. Okay, and for this second example, we're going to solve for V. Notice it has a square on it, so we're going to end up having to take the square root once we get it isolated. So I'm going to multiply both sides by V squared, because that's what my denominator is, my least common multiple. So I get V squared M is equal to 2E. I'm going to move this way. I'm going to divide both sides by M, and I get V squared is equal to 2E over M, and then I'm going to take the square root. And I get V is equal to the square root of 2E over M. Okay? All right, this is what we're going to work on in class. So if you need to pick and choose a few just to make sure you understand what's going on, you might want to try that. And then I'll see you tomorrow. Thanks for listening to my instruction video.